Hello, this is Dr. Hanaa Assil, and this is a review on the IGCSE Chemistry Cambridge syllabus. This is for the syllabus of 2023-24. So let us take a look at a final review on the core subject. And this is the first part of it. So let's talk about, we're supposed to know separation of particles, arrangement of particles, and movement of particles in a solid, a liquid, and a gas. So we're supposed to know that for solids, if we're asking about separation, they are close packed, touching. For liquids, they are near each other in clusters, and for gas, they're far apart. And please note, if we're asking about separation, do not mention anything else about movement, for example. How are the particles arranged in a solid? They are regular rows, so this is the arrangement. Liquids, random arrangement. Gas, random arrangement. What about movement? How do the particles in a solid move? They vibrate in fixed position. Please don't say they don't move. For a liquid, they move around each other. For a gas, fast, free, random motion. Please remember, is the question asking about separation or arrangement or movement? Then you should know the different changes of state. Of course, if we heat a solid, it changes into liquid, that's melting. So melting is the change from solid to liquid. Heat the liquid further, it will boil. Boiling is the change from liquid to gas at a specific temperature. Now, if we cool the gas, it goes back, and this is condensation. And if we cool the liquid, it becomes solid, and that is freezing. Of course, you should know that if I heat a solid, for some solids, they change directly into gas. You cool the gas, it changes directly into solid. That is sublimation. So sublimation is the change from solid to gas or gas to solid. You should also know the difference between evaporation and boiling. Remember, both evaporation and boiling are change from liquid to gas. But remember, evaporation is change from liquid to gas at any temperature, while boiling happens at a fixed temperature. Also, evaporation occurs only on the surface of the liquid, while boiling occurs throughout the liquid. Remember, the pressure of a gas is due to particles hitting the inner surface of the container. So if we heat up this gas, or we increase the temperature of the gas, then the particles will have more kinetic energy, move faster, hit the sides of the container faster, and therefore the pressure would increase. And that's why a balloon left in the sun, the pressure inside would increase until it bursts. Now, we know that we can be provided with information about melting point and boiling point, and we're required to know if something is a solid or a liquid or a gas at a specific temperature. So if we're talking about room temperature, if something is a solid at room temperature, that means the melting point and boiling point are very high. So if we're told that the melting point and boiling point of a substance is very high or higher than room temperature, then at room temperature, then it is a solid. But if something is a liquid at room temperature, that means it has already melted. That means we have already passed the melting point, while we have not reached the boiling point, and that's why it's not a gas. So if something is a liquid, we say it's a liquid because the melting point is lower than the temperature we're talking about, which in this case is room temperature, while the boiling point is higher. Now, if something is a gas at room temperature, that means it has already melted and it has already boiled. So we say it's a gas because the boiling point and melting point are lower than room temperature. Pure substances are those that contain no impurities. So a pure substance would have a fixed melting point and a fixed boiling point. But if we have impurities, the presence of impurities will cause, first of all, the melting point to be lower. So an impure substance would melt at lower temperature than it should, and it will melt over a range. It will not melt sharply at a specific temperature. Now, if we're talking about a liquid and the liquid is impure, then it would boil at a temperature that is higher than the usual boiling point. So presence of impurities, they cause the melting point to be lower, but the boiling point to be higher. And in both cases, it melts or boils over a range, not sharply. That tells us that it is impure, or it's what we call a mixture. So what is diffusion? Diffusion is the movement of particles from an area of high concentration to an area of low concentration down the concentration gradient. So if we have particles or crystals of potassium permanganate, which is purple, we put it at the bottom of the beaker. These molecules or these particles will gain kinetic energy, move faster, overcome the attraction forces between them and move further apart, and then they will move from area of high concentration, which is at the bottom of the beaker where we have a lot of the crystals, to area of low concentration, which is at the top of the liquid, and this is by the process of diffusion, so that after some time all the liquid becomes purple color. We can also have diffusion of a drop of ink in water, so this is diffusion of liquids in liquids. We also have diffusion of gases if we have on one end a cotton wool with ammonia, on the other end a cotton wool with concentrated HCl. The particles will move from area of high concentration, so the ammonia on the cotton wool is area of high concentration, so it will move from area of high concentration to where there is no ammonia, while the particles of the HCl will move from area of high concentration to area of low concentration. Now, where do they meet? That depends on how fast the particles are diffusing, and we should know that particles that are lighter, lower molecular mass diffuse faster. In this case, if you determine the molecular mass of ammonia, molecular mass of HCl, ammonia is lighter, lower molecular mass, so the particles diffuse faster, so the particles of the ammonia meet with the HCl nearer to the HCl. Now, when ammonia reacts with HCl, it forms a white cloud of ammonium chloride. What's an element, compound, mixture? You should know an element is a substance that contains only one type of atom. So all the atoms are the same, that's an element. They could be individual atoms, in that case we call them monatomic, or they could be in twos, so in that case the molecule is diatomic, but either way, if all the molecules are the same, that's an element. Now, a compound is made up of two or more elements chemically combined together in a fixed ratio. So each of these molecules are the same, but they are made up of two or more elements chemically combined together, so that is a compound. Now, what's a mixture? A mixture is where we have different substances. They could be elements, they could be compounds, so a mixture is made up of two or more substances added together. They are not chemically combined and they can be separated easily. So, for example, if I want to separate sand from water, that's a mixture. Sand is something that is insoluble in water, then we use filtration. So we filter the mixture through a filter paper and funnel. Of course, the sand will remain in the filter paper, and that's what we call residue. And the water will go down into the flask, and that is what we call the filtrate. What if we want to obtain crystals from a solution? So I have an aqueous solution of copper sulfate and I want crystals. Then we do the process of crystallization. In crystallization, what we do is heat the solution to point of crystallization. Then we cool to form crystals, filter this mixture through filter paper and funnel. In that case, the crystals will remain as residue in the filter paper. Now wash the residue with a few drops of distilled water and dry between filter papers. Of course, to know the point of crystallization, how do I know if we have reached point of crystallization? Insert a glass rod into the hot solution and remove it. Crystals should form on the tip. Now, when we heat a solution to point of crystallization, what we end up with is called a saturated solution. So a saturated solution is one in which no more solid can dissolve at a certain temperature. So when we heat to point of crystallization, we end up with saturated solution. And then when we leave it to cool, then when it becomes at lower temperature, then the crystals will not dissolve anymore. What if we have a solution, but we want the water, not the crystals? So if we want the solid or the salt, we do crystallization. But what if we want the water? We do simple distillation. So in this case, we heat the solution in a flask connected to a condenser. The liquid boils, evaporates, condenses. It cools and condenses in the condenser to give a pure liquid, which we call the distillate. The thermometer in the flask records the temperature of the distillate or the temperature at which the liquid boils. Remember that in the condenser, the cold water goes in from down and goes out from the top in order to fill the condenser for more efficient cooling. What if we have a mixture of liquids, ethanol and water? Ethanol and water, then we need to do fractional distillation, in which the solution is heated in a flask connected to a fractionating column and condenser. The liquid with the lower boiling point is the one that evaporates first. It rises in the fractionating column and then cools and condenses in the condenser, and it is collected in a separate receiver as a separate fraction. Then after that, when the temperature starts to rise again, then we can collect the other fraction. So the word fraction means a collection of liquids having similar boiling points that are collected together. In paper chromatography, we use paper chromatography in order to determine the number of components. For example, I want to know how many dyes in ink. Then we put a spot of the sample on a baseline near the bottom of the rectangular chromatography paper, place the paper in a beaker containing a very small amount of water if we're talking about ink, or we could use ethanol, allow the solvent to move up the paper, and we can determine the RF value. The RF value is the distance traveled by the spot divided by the distance traveled by the solvent. So measuring the distance from the baseline to the spot divided by the baseline to. Then let's talk about atomic structure. We said an atom is made up of a central part called the nucleus, and inside the nucleus we have neutrons and protons. And remember that the neutron and protons have a mass of 1. The charge on a proton is +1, the charge of an electron is -1, and the electron has a very, very small mass. Remember that both neutron and proton, the subatomic particles present inside the nucleus, are called nucleons. So, when you look at the periodic table, you will have two numbers. The smaller number is what we call the atomic number. The atomic number is the number of protons, and this is usually equal to the number of electrons, unless if the atom has lost or gained electrons. Now, the larger number is the mass number, or the nucleon number. This is the total number of protons and neutrons. So if we want the number of neutrons, we subtract the big number minus the small. Electron configuration means we arrange the electrons. So aluminium has a small number 13. That means it has a total of 13 electrons. Now, how are they distributed? The first shell has 2. The next can take up to 8. And I still have 3 more. So we put it in the last. So an atom may lose electrons. Atoms in group 1 or 2 or 3 have 1 or 2 or 3 electrons in their outermost shell. They would tend to lose electrons. At the beginning, the atom has equal number of protons and electrons, but if it's going to lose that outermost electron, that means it has more protons than electrons, and that means it has an extra positive charge, and it becomes a cation. So remember, a cation is an ion that has a positive charge. Now, some atoms may gain electrons. So something in group 7, for fluorine, for example, has equal number of protons and electrons, but it has 7 electrons in its outermost shell. So it needs to gain 1 to have a full outer shell. When it gains 1 electron, now it has an extra negative charge, so we need to put a negative charge on it, and this becomes what we call an anion. Isotopes are atoms of the same element having the same number of protons but different number of electrons, and the relative atomic mass of an element is the average of the mass numbers of the different isotopes in ratio of their occurrence. And remember, all masses are relative to the mass of carbon-12 atom. Periodic table, please notice the periodic table. The vertical columns are called groups and the horizontal rows are called periods. The number of the group is the same as the number of electrons in outer shell, while the number of the period is the same as the number of shells or number of energy levels. So if we look at the periodic table, remember the metals are groups 1, 2, 3 and everything in between. These are metals. From group 4 to the right end of the table, these are non-metals. You should know that group 1 are called alkali metals. The ones in the middle there are called transition metals. The ones in group 7 are called halogens, and the ones in group 8, or we sometimes refer to it as group 0, these are noble gases. So group 1, what do we know about group 1? They all have 1 electron in their outermost shell. So they are very reactive and they are soft metals, very reactive, so they have to be stored under oil. So if we say why are they stored under oil, that's because they're very reactive to prevent them from reacting with oxygen and water vapor in the air. They are very soft, so most of them can actually be cut with a knife. Now, which ones are more reactive? You should realize that as we go down, the one down is more reactive. Now, why is that? Remember, a metal is reactive if it can lose its outer electron. So comparing these as we go down, which would be easier to lose the outer electron? Remember, the lithium on top, the outer electron is very near to the nucleus, strong attraction forces between the electron and the positive nucleus. But as I go down, the number of shells increases. So potassium, for example, there is less attraction forces between that outer electron and the positive nucleus. So that is why potassium is more reactive. As we go down, cesium is the most reactive metal in the periodic table. And we should know what's happening to the density, what's happening to the melting point. Remember, as we go down, the one up has lower density but higher melting point. As we go down the group, it becomes more reactive, higher density, but lower melting point. So all of them, compared to the other metals, have low density. So we put them in water, they will all float on the water. But which one is more reactive? The one down. So potassium will explode if you put it in water, while the other metals would, sodium would maybe catch fire. Lithium would give a very slow reaction in water. That means that potassium is more reactive than lithium, but remember the melting point decreases as we go down. Transition metals. You should be familiar with the physical properties of transition metals. They're all very hard, very high density, very high melting point. If we're talking about chemical properties, then you should know that compared to other metals, the transition form colored compounds, while any other metal in any other group does not. Transition metals act as catalysts, and transition metals may have more than one valency. So we say iron, for example, can either be valency 2 or. So if we compare physical properties of transition metal with any other group, like group 1, transition are very hard, very high density, very high melting point, while something in group 1, for example, is soft, lower density, lower melting point. If we're comparing chemical properties, we said transition metals form colored compounds, while group 1 do not. They don't have a color, so they are white solids or colorless solution. Also, transition metals, we said, may act as catalysts, may have more than one oxidation state, which is similar to the valency. While group 1 do not act as catalysts, and they have a specific oxidation state or a specific valency. Halogens. Halogens are the ones in group 7. So we have fluorine, chlorine, bromine, iodine, astatine, and we actually have another new one down at the end of that group. All of them, each of them has 7 electrons in its outermost shell. They are very reactive nonmetals. Now, which one is more reactive? Remember, the one up is the one more reactive. Now, remember in group 1, we said the one down is more reactive because it's more likely to lose its outer electron. Now, in group 7, we want to gain. So we want the electron to come in and be attracted to the positive nucleus. So fluorine has less shells, so there will be more attraction to the positive nucleus, so it is more likely to take in more electrons, while something like bromine has more shells, so the electron that is being added has less attraction to the positive nucleus. So you should know that fluorine is the most reactive nonmetal. If we're talking about appearance, you're required to know the appearance. So fluorine is a yellow gas, chlorine green gas, bromine is reddish brown liquid. So this is the only liquid nonmetal. Iodine is gray solid, astatine would be a black solid. So as we go down, the one up is most reactive, but as we go down, the melting point increases, density increases, and the color gets dark. Remember that the more reactive nonmetal displaces the less reactive nonmetal from its salt. So which one here is more reactive? The one up. And that means the one up will displace the one below it. So if I have chlorine plus potassium bromide, the chlorine is more reactive. It will displace the bromide to form bromine, and you should know that chlorine as a gas is green. Now, what is potassium bromide? Potassium bromide, this is a compound of group 1. It's colorless. But when we put in chlorine gas or chlorine solution, then the chlorine will displace the bromine and we start to have an orange solution due to the formation of bromine. And you should be familiar with writing the balanced equations for these. So chlorine plus potassium bromide would form bromine. Remember, chlorine, bromine, all of these are diatomic. That means if I write chlorine, the molecule has 2 atoms. That's what diatomic means. Also, chlorine can displace iodine. So in this case, the potassium iodide again is colorless. When we displace it, it forms a reddish brown solution of iodine. But remember, the one below, the one that is less reactive, cannot displace anything above it. So if we say iodine plus potassium bromide, no reaction, because iodine is less reactive than bromine and would not displace it. Okay, noble gases are in group 0. They are monatomic gases. They are unreactive because they have a full outer shell. So they are inert or unreactive because they have a full outer shell. So helium has 2 electrons, but this is the first shell and it's full with 2. Now neon has a second shell that's full, 8. Argon has a third shell that's full, 8 electrons, and so on. What do we use helium for? For filling balloons. Argon for filling light bulbs. Neon for fluorescent lights. Okay, let's talk about bonding. Ionic bonds are the strong attraction forces between positive and negative ions. Ionic bonds are formed when a metal loses electrons and becomes positive, and a non-metal gains electron and becomes negative. So the strong attraction force, electrostatic attraction force between the positive and negative ions, or the oppositely charged ions, this is what we call ionic bond. So how do we draw dot and cross diagrams? You should be familiar with dot and cross diagrams. Please practice all of this. Lithium fluoride. Lithium, first of all, lithium is a metal, fluorine is a non-metal, so one of them will lose and the other will gain, so I have to write it like this. So lithium has 1 electron out of a shell. It's going to lose it and become a positive ion, which we call a cation. Now fluorine has 7 in its outer shell. It needs 1 more. So it's going to take the 1 from the lithium, and that means now it has an extra electron, so it has a minus or a negative charge on it. What about sodium oxide? Now, sodium has 1 electron out of a shell. It's in group 1. It has 1 electron out of a shell. It's going to lose it and become Na+. But the oxygen is in group 6. It needs 2. Now, where is it going to get the 2? From another sodium ion. So I have 2 sodiums losing 2 electrons or 1 electron each to form a positive ion, while the oxygen gains 2 electrons, so it becomes 2 negatives or -2. Magnesium chloride. Magnesium can lose 2 electrons and become Mg2+, but each chlorine needs only 1 more electron. So I need 2 chlorines to receive the 2 electrons coming from the magnesium, and in that case each chlorine has the 7 of its own in the outer shell plus the extra electron is going to take from the magnesium, so it has an overall negative charge. Please do not forget to write the positives and the negatives. Some students write the dot and cross and totally forget about whether it's a positive ion or a negative ion. You should know that ionic compounds have high melting point and boiling point. This is because there is strong attraction forces between the positive and negative ions, and this needs a lot of energy to break and separate the ions. Ionic compounds conduct electricity when molten or in solution, not when solid. This is because when molten or in solution, the positive and negative ions, not electrons, ions are free to move. They don't conduct electricity when solid because the ions are fixed when solids. They form what we call a crystal lattice and they cannot move, so they do not conduct electricity. What's a covalent bond? Well, covalent bond, remember, is sharing of a pair of electrons between nonmetals. So you can say that the covalent bond is sharing of electrons, a pair of electrons between two nonmetals. We can also say that it is the attraction force between the shared pair of electrons and the positive nuclei of the atoms. How do we draw a dot and cross diagram for something like hydrogen? Hydrogen molecule means I have two hydrogen atoms. Each of them have one and need how many? They need just one more because this is the first shell, and the first shell can take only two. So this is the dot and cross for hydrogen molecule. What about chlorine? Chlorine with chlorine, each chlorine needs one, so they're going to share a pair of electrons, and don't forget that they still have the rest of the 7. Each of these chlorine atoms had 7 electrons in its outer shell. It used only one of them, so each of them still has 6 electrons around in that shell. What about water? Water is between oxygen and hydrogen. Oxygen needs 2, but each hydrogen can donate only 1, and that is why we have 2 hydrogens reacting with or bonded to 1 oxygen. Okay, what about methane? You should know that methane is carbon with 4 hydrogens. Now, each hydrogen has 1 and needs 1. And the carbon is in group 4, and that means the carbon has 4 of its own that it's going to use for sharing, and it's going to share with 4 hydrogens. So now each of them has a full outer shell. Ammonia, nitrogen has 5 electrons in its outer shell. It needs 3. So we have 3 hydrogens donating an electron each, but we still have the rest of the 5 from the nitrogen, so don't forget that pair of electrons that is away from the sharing. Please practice all of these. Hydrogen chloride, that's hydrogen with chlorine, and we said hydrogen needs 1 and chlorine needs 1, so they're going to share a pair of electrons, but the chlorine still has the rest of its 7, so don't forget that it has 6 electrons around away from the share. Okay, what's the difference between simple molecular structures and giant structures? You should know that simple molecular structures like water, for example, or carbon dioxide have weak attraction forces between molecules, and these attraction forces are called intermolecular forces. Are we paying attention? So, simple molecular structures like water, carbon dioxide, iodine, any compound that is simple would have low melting point. Now, why does it have low melting point? Due to the weak attraction forces between what? Between molecules, and these are called intermolecular forces. So these need a small amount of energy to be broken, so we don't need to heat it to a very high temperature. But giant macromolecular structures like ionic compounds or metallic structures, so all metals are giant, or diamond and graphite. So the ionic crystals have many positive, negative ions in a giant 3-dimensional structure, which we call a crystal lattice. Metals are many atoms in regular rows, closely packed with a sea of delocalized electrons. Diamond and graphite have many carbon atoms that have strong covalent bonds between them. All of these are called giant structures or macromolecular structures. So diamond, for example, you should know it's giant, 3-dimensional, in which each carbon atom is covalently bonded to how many? To 4 other carbon atoms in a rigid tetrahedral structure. So diamond is hard. And why is it hard? Because of the strong covalent bonds between the carbon atoms in the rigid 3-dimensional tetrahedral structure. Diamond does not conduct electricity. Each carbon atom had 4 electrons. It's bonded to 4 other carbons. So there are no free electrons to conduct electricity. Remember, if we say what is the use of diamond, we say in cutting equipment or in cutting tools or in drilling equipment, because it is hard. Now, why is it hard? We said it because of the strong covalent bonds between the carbon atoms in the rigid three-dimensional tetrahedral structure. You should also know that this is a element. The giant diamond has high melting point because it has many strong covalent bonds in the rigid three-dimensional tetrahedral structure, and this needs a lot of energy to be broken. Graphite is also giant, three-dimensional, but each carbon is covalently bonded to only 3 other carbons, so that means that each carbon has an extra electron floating around somewhere, and it is in layers of 6-sided rings with weak attraction forces between the layers. Please learn all of this. Now, because of that, graphite is soft, and because it is soft, we use it as a lubricating agent. Now, why is it soft? Because the weak attraction forces between the layers allow them to slide over each other. So graphite is soft because of the weak attraction forces between the layers that allow them to slide over each other. Now, because it is soft, it is used as lubricating agent or lubricant. Now, graphite is the only non-metal that conducts electricity, and that is because it has delocalized electrons that are free to move. So graphite conducts electricity because it has delocalized electrons that are free to move. What do we use graphite for? Remember, we use it as a lubricant because it is soft, and we also use it in electrodes because it conducts electricity. How do we write formula and equations? Remember, the word molecular formula means a formula showing the number and types of atoms in a molecule. So if we're given the diagram, we can tell that a compound like this, for example, has 1 iron, 5 carbons, 5 oxygens. So to write the molecular formula, we write it like this. But in most cases, we're required to write the molecular formula from the name. So we're given the name and we need to write the molecular formula. In that case, we write the symbols of each element and then put the valency of one under the other. So what is the valency? Anything in group 1 would have valency 1. Valency is the number of electrons lost or gained in order to have a full outer shell. So anything in group 1 has 1 electrons out of a shell. It needs to lose 1, so its valency is 1. Anything in group 2 has 2 electrons in its outer shell. It needs to lose these 2 electrons, so its valency is 2. Also, anything in group 3, valency 3. Anything in group 4, valency 4. What about anything in group 5? Well, in group 5, it will need to gain 3 electrons, so its valency is 3. Anything in group 6 needs to gain 2 electrons, so valency 2. And anything in group 7 needs to gain 1 more, so the valency is 1. These atomic groups you need to learn. If we say something hydroxide, it's OH, valency 1. Nitrate, NO3, valency 1. Nitrite, NO2, valency 1. Ammonium, NH4, valency 1. Remember, there's something called ammonia and something called ammonium. Ammonium is NH4. Carbonate is CO3, valency 2. Sulfate, SO4, valency 2. Phosphate, PO4, valency 3. Please learn these. You will not be able to write a chemical formula without knowing these. For transition metals, we said transition metals have more than 1 valency. So if we're told iron, the question needs to tell us, is it iron 2 or iron 3? Copper is usually 2, silver is usually 1, and zinc is always 2. To write acids, we write H first, and then the atomic group. So hydrochloric acid is an acid that has chlorine, so HCl. Nitric has nitrate, sulfuric has sulfate, phosphoric has phosphate, and carbonic has carbonate. And then you write the valency of one under the other. Of course, the valency of hydrogen is 1. Now, something like sulfate has a valency of 2, so we put 2 under the H. Phosphate, valency 3, we put 3 under the H. Carbonate, valency 2, we put 2 under the H. Then sometimes we are given an indication that we have an exception. So, for example, nitrogen monoxide. The word mono means 1. So I put nitrogen with 1 oxygen and forget about valencies. Carbon monoxide is CO, 1 oxygen, forget about valencies because these are exceptions. If you sit down and do valency of each of them and put it under the other, there would be a mistake. Nitrogen dioxide means nitrogen and 2 oxygens. Carbon dioxide, sulfur dioxide means we put 2 oxygens. Trioxide means we put 3 oxygens. And then we will be required to write balanced chemical equations. So we write all the chemical formula of the reactants and the products, and we balance the equation. We count before and after the arrow and increase the one that is less. If we are required to write state symbols, you should know that S is for something that is insoluble or a solid. L is for liquid, and usually L is given to water, all to be R2 if it's a liquid. G for a gas, AQ for anything that is aqueous, that means dissolved in water. You should know that some molecules are diatomic. As we said, diatomic means the molecule has 2 atoms, and you should know that these are the ones in the periodic table that are diatomic: hydrogen, nitrogen, oxygen, and everything in group 7. So to write a balanced equation, we said chlorine, for example, plus potassium iodide. Chlorine is diatomic. Potassium iodide, valency of potassium is 1, iodide is 1. To give iodine plus potassium chloride, and you count the number of chlorines before and after the arrow, number of iodines and potassium. So you need to put coefficients in order to balance. So the 2 in front of the potassium iodide, 2 in front of the KCl. These are coefficients to make sure that the number of atoms are the same before and after the arrow. Again, barium chloride plus sulfuric acid. Remember, sulfuric acid is written so that it is H2SO4. Barium chloride, valency of barium is 2. It's in group 2. So I need to put the 2 under chlorine, but the valency of chlorine is 1, so I don't put anything under the barium. Now for barium sulfate after the arrow, valency of barium is 2, but also valency of sulfate is 2. So when both of them are 2, they cancel and we don't write 2 under any of them. And hydrochloric acid, and I need to balance to have 2 chlorines and 2 hydrogens. After the arrow, I put 2 in front of the HCl. Okay, what is an acid and what's a base? Remember that acid is defined as proton donor, and the word proton means H+, because hydrogen is something that has only 1 electron and 1 proton in the nucleus. So if it is H+, that means it lost its electron, so it's just an atom with only a proton in the nucleus, so we call it a proton. So an acid is defined as a proton donor, something that gives H+. Remember that presence of H+ in the solution, this is what makes it acidic. So if we say which ion causes that solution to be an acid, it's the presence of H+. A base is a proton acceptor, and when we dissolve it in water, it gives OH-. So if we say which ion causes the solution to be a base or an alkali, we call it an alkali, it is the presence of the OH- ion. So an alkali is a base that dissolves in water. Now, when acids react with bases, what comes out is called a salt. So salts are ionic substances produced from reaction of acids and bases. Now, an acid or a base may either be concentrated, and that means we have only a small amount of water added to it, or dilute, and that means it has a lot of water added to it. Remember, to determine if something is an acid or a base, we use universal indicator paper, and we use a number called the pH. Acids have pH less than 7, base has pH higher than 7. Anything that's pH 7 is neutral, like water or salts. Strong acids would have pH 1 or 2 or 3. Weak acids would have pH 4, 5, or 6. A weak base has pH 8, 9, or 10. And a strong base, anything that's hydroxide, would have a pH higher than 11. How do we know the pHs, or how do we know if something is an acid or a base? We put indicator. So an indicator is a substance that has different colors, or it changes colors in acids and bases. So for example, to know if something is an acid or a base, the easiest way would be to put litmus paper. If the litmus turns red, it's acid. If the litmus turns blue, it is a base. But if we want to know what exactly is the pH, we insert universal indicator paper and compare the color to the chart. So whatever color comes out, we compare it to this chart, and we can determine the pH of the solution. When we're doing titration, we need a liquid indicator, so we can either use thymolphthalene. So please know the colors. Thymolphthalene in a base is blue. If it becomes neutral or acid, it is colorless. Methyl orange is another indicator. If we put it in a base, it's yellow. Neutral, it's orange. And acidic would be red or pink. Reactions of acids and bases, these are very important. First of all, when an acid reacts with a base, it gives salt plus water, and this is called neutralization reaction. So if I have an acid like HCl, so its pH is something around 2. A base like sodium hydroxide would have a pH of about 12. Now this gives salt and water, and these are both pH 7, so we have neutralized the solution. That's why it's a neutralization reaction. Now I want you to pay attention to this ionic equation for neutralization reaction. Remember, we said an acid is something that has H plus ions. A base is something that has OH minus. Now, when H plus reacts with OH minus, this is how we get water, H2O. So please remember that this is the ionic equation for neutralization reaction. H plus, which is aqueous, plus OH minus, which is aqueous. We said aqueous means dissolved in water. This gives H2O, and the H2O is a liquid. So acid plus base gives salt plus water. What about acid plus metal? Acid plus metal will give salt plus hydrogen. Acid plus metal gives salt plus hydrogen. Acid plus carbonate, anything carbonate, sodium carbonate, calcium carbonate, this will give a salt plus carbon dioxide plus water. So HCl, for example, with calcium carbonate. Now what is the salt? The salt is calcium chloride plus carbon dioxide plus water. Ammonia is a base, but it's a base that doesn't have OH. So when it reacts with acid, it gives only salt. So if I have ammonia plus, and ammonia please is NH3, it reacts with acid, it gives ammonium something, which is NH4. So with hydrochloric, it gives ammonium chloride. With nitric, it gives ammonium nitrate. With sulfuric, it gives ammonium sulfate. If you remember, the valency of ammonium is 1, but the valency of sulfate is 2. So this is how we write ammonium sulfate, and we need to balance. With phosphoric acid, it gives ammonium phosphate. Valency of phosphate is 3. So you should know that oxides of most non-metals are acidic. So carbon dioxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide, all of these are acidic oxides, and that means they will react only with a base. Some metals, or most metal oxides, are basic. So calcium oxide is a base, copper oxide, and so on. So oxides of most metals are basic, and that means they react only with acid. Remember that this is the core syllabus. So for year 10 or for the IGCSE supplement or extended, we have another video that will talk about the other different types of oxides. But for now, this is the core basic. You should know that acidic oxides are oxides of nonmetals. Basic oxides are oxides of metals. Okay, so acidic or basic means if I dissolve it in water, it would either form a base like magnesium oxide or an acid like carbon dioxide, sulfur dioxide. Remember that sulfur dioxide in water forms an acid called sulfurous acid, while sulfur trioxide forms an acid called sulfuric acid. How do we prepare salts? Well, that depends. Which type of salt are we preparing and what are we preparing it from? So we need to know which substances are soluble, which substances are insoluble. You should remember, any nitrate is soluble. Soluble means it forms an aqueous solution. Sodium salts, sodium anything, potassium salts, ammonium anything, all of these are soluble or aqueous. All acids are soluble. Things like barium chloride, copper sulfate, these are soluble and they form aqueous solutions. Most of the other substances are insoluble. So most carbonates are insoluble. Insoluble means they will form a precipitate. The chloride bromide iodide of silver or chloride bromide iodide of lead, all of these are insoluble. Barium sulfate is insoluble. Copper oxide, of course, is a solid, so it's insoluble. All metals are insoluble. So if we're trying to make sodium chloride is soluble. We make it from what? We make it from sodium hydroxide and HCl. All of these are soluble, so we do a method called titration. In titration, we need to know exactly how much acid I should add to the base in order to form salt plus water. We don't want excess acid and we don't want excess base. So we put a specific amount of sodium hydroxide or a base in the flask using a pipette. We add an indicator. So if we add methyl orange to the base, the solution turns yellow. Now we add HCl from the burette until the methyl orange turns from yellow to orange, and we know the amount of acid used. So now I know how much acid I should add. We throw away that flask and we repeat again without indicator. So we add 25 centimeter cube of sodium hydroxide and the required amount of acid. Now I know that this is a neutral solution. I heat to point of crystallization, cool, filter the crystals, wash with a few drops of distilled water and dry between filter papers. What if I am trying to make something like copper sulfate, but we're starting from something that's not soluble? For example, copper oxide. Then we do a method called neutralization. In neutralization, I add excess of the solid. So for example, excess of copper oxide to the sulfuric acid until, how do I know it's excess? I see solid remaining in the beaker. I filter off that solid to remove it, and I take the solution, heat to point of crystallization, cool, filter the crystals. If I'm trying to make something that is insoluble, so I'm trying to make something that precipitates out, and this is called a precipitation reaction. So we add two solutions and they form a precipitate. Silver nitrate, for example, plus sodium chloride will give a precipitate of silver chloride, and this is what we want. So we filter and we wash the residue dry between filter papers. Tests, please learn the tests also for the paper 3 or paper 4. You are required to know the tests because they will ask you some of these. So you should remember that test for carbonate is add dilute HCl. I get bubbles of gas that turn lime water milky. Test for halides, chloride, bromide, iodide, we add dilute nitric acid and aqueous silver nitrate. If it's chloride, we have white precipitate, bromide, cream precipitate, iodide, yellow precipitate. What about test for nitrate? For nitrate, we add aqueous sodium hydroxide, aluminum foil, warm gently, we get bubbles of gas of ammonia gas. How do I know it's ammonia? Turns damp red litmus paper to blue. Please revise all of this. Test for sulfate, nitric acid and barium nitrate solution. This gives a white precipitate. Sulfite, we use potassium permanganate to identify the sulfur dioxide gas that is coming out. So when we add dilute hydrochloric acid and warm gently, it gives off sulfur dioxide gas. How do I know it's sulfur dioxide gas? I pass it through aqueous potassium permanganate. It turns from purple to colorless. Test for aluminium. Remember, add sodium hydroxide with aluminium. It gives white precipitate soluble in excess, giving a colorless solution. With aqueous ammonia, it gives a white precipitate that is insoluble in excess. Test for ammonium ions, we add sodium hydroxide. On warming, it gives off bubbles of ammonia that turn damp red litmus paper to blue. Test for calcium, we add sodium hydroxide. It gives a white precipitate insoluble in excess. Add aqueous ammonia, it gives no precipitate or very slight white precipitate. That's for calcium. What about chromium? Chromium gives a green precipitate with sodium hydroxide that dissolves, that is soluble. With aqueous ammonia, it gives a gray-green precipitate that is insoluble. Please learn all of these. You might get questions in paper 3 or paper 4 on these. Of course, these are very important for paper 6, but they are also important for paper 3 or 4. So, copper, add aqueous sodium hydroxide. With sodium hydroxide, the copper gives light blue precipitate insoluble in excess. Please note, is it insoluble or soluble? With aqueous ammonia, I also get a light blue precipitate, but this is soluble in excess, giving a dark blue solution. Ion 2 with sodium hydroxide or ammonia would give green precipitate. Ion 3 with both of them gives reddish brown precipitate. And zinc with both of them gives a white precipitate soluble in excess, giving a colorless solution. Remember, test for gases, ammonia, it turns damp red litmus paper to blue. Carbon dioxide turns lime water milky. Chlorine bleaches litmus paper. Now hydrogen and oxygen, please remember which one uses lighted and which one uses glowing. So hydrogen uses a lighted splint, it pops. Oxygen, we use a glowing splint, it relights. Flame tests. Remember, to do a flame test, we need to clean the platinum wire by dipping it in concentrated HCl. So this is to remove any impurities. Then dip the wire in the salt, expose the wire to the hot flame of the Bunsen burner, and observe the color. You have to learn these colors. lithium is red, sodium yellow, potassium lilac, calcium brick red, barium green, copper blue green. Please learn all of these. Of course, what is the chemical test for water? We either add anhydrous copper sulfate, it turns from white to blue, or anhydrous cobalt chloride, and it turns from blue to pink. But if I want to test for pure water, then I heat to boiling. It should boil at 100 degrees Celsius. What is test for alkenes or test for unsaturation? Remember, an alkene is unsaturated. Add bromine water, it turns from reddish brown to colorless. What is test for ethanol? Put a lighted splint, it catches fire. Remember that alcohols are flammable. Or it gives an antiseptic smell. What is the test for ethanoic? Ethanoic is something that has the smell of vinegar. These are colors you are required to know. Please learn these colors, and we're going to stop here and we'll continue in part 2. So please make sure you study all of these. These are the core, and we'll have a part 3 for the extended or the supplement, which is the extended part of the syllabus.